Today we're going to look at exponential equations, and we're going to have two things we specifically want to look at. First is a change of base formula, and this is a formula we've kind of held off on showing you until this point, and it will allow us to do things on our calculator to allow us to solve more types of problems. And then we're going to use that change of base to solve exponential equations. And so we have to first do the change of base before we can solve the equations. Now, before we get to the change of base formula, let's look at some examples. If I have log base 2 of 1/8, remember that's 2 to what power is 1/8? It's a fraction, so we get a negative. 2 cubed is 8, so we get -3. Log base 27 of 3. 27 to what power is 3? That is 1/3. But when we get log base 4 of 10, 4 to what power is 10? Now that's a little harder. We can't just think about that one because it's going to be some decimal, it's not even going to be a fraction, it's going to be a decimal, that we're going to try to get our 10. 4 to what power is 10? Now, we know 4 to the first is 4. We know 4 squared is 16. But to get 10, it's got to be something in the middle. How can we find that? Well, before we show you the formula, let's talk about where the formula kind of comes from. Let's say we want to know log base 4 of 10. So we want to determine 4 to what power is 10. Well, if I write that in exponential form, that's 4 to the x equals 10. We've done that most of this chapter. Now, let's use some of our properties of logarithms. Let's take the natural log of both sides. So if I take the natural log of both sides, natural log of 4x equals natural log of 10. Now, by my properties of exponents that we know, this number in front can come out in front. So x times natural log of 4 equals natural log of 10. And let's stop there for a second. Look at what that did. We have now taken this exponent, this variable that's up here, which we have not been able to solve for yet. And by using this property, we moved it down in front, where now it's just a multiplication. So we've gone from an exponent, a power, to multiplication. Now I can just solve this by dividing both sides by natural log of 4. So I've solved for x. X is natural log of 10 divided by natural log of 4. So the question was, 4 to what power gives me 10? There's my answer. I could take the natural log of 10, too many natural logs, that one. The natural log of 10 divide by the natural log of 4, I get 1.66. We said it's between 1 and 2. And now notice if I take 4 to that, we won't use all the digits and round off, so we'll just get close. I get 10. If I used all the digits, I'd get exactly 10. So this shows you how we're able to find 4 to what power is 10. We can actually solve for it. Now, what this ends up with, if we do this in a general case, we get what's known as the change of base formula. Now, don't write what I'm going to write down first here because I want something better going forward. The change of base formula says this. I can write log base b of a to log base c of a over log base c of b. I can write this to any base I want. Now, if we can write this to any base we want, I'm not going to want to use base 2. I'm not going to want to use base 7. I'm going to use a base that's on my calculator. So I can write this as the natural log of a over the natural log of b. So log base b of a, I can write natural log of a over natural log of b. And that's what we got when we solved over here. Log base 4 of 10 equaled natural log of 10 over natural log of 4. Now, if it can be any base, this also would technically be the common log of a over the common log of b. That would also work. Let's look at this example. Log base 3 of 20. This is the natural log of 20 over the natural log of 3. So if we put that in our calculator, this is the natural log of 20 divided by the natural log of 3. Make sure you get the parentheses right and are careful to put parentheses in there. We get our answer. Now, many of you don't like natural log. It's got that E built in there. It just makes you very nervous. We all like common log. We like 10. 10's a nice number. So much nicer than E. So we like to use 10 better. So we could use common log. And I could do the common log of 20 divided by the common log of 3. And you get the exact same answer. So really, you could also write this as the common log of 20 over the common log of 3. That would work just as well. And then what do we get? 2.727. Always go 3 decimal places when we do these. Okay. So we could use natural log or common log. I will almost always use natural log for one reason, and that is I'm lazy, and ln is just 2 letters. It's quick to write. To write the common log, it's L, O, G. That just takes forever. You know, ln, quick, shorter. So that's why I like ln better. Now, seriously, as we go forward, especially in calculus, we do everything with ln. We don't use common log. Why that is now is not important, but going forward it is. So you can use either one. I'm going to use ln going forward here. You could use either one. So if we want to solve 3x equals 7, now we can use our change of base formula. We could say, well, I could just write that as a logarithm, as log base 3 of 7 equals x. You have to know how to put it from exponential form, into logarithmic form. Have to know that. So we want to put it in log form here. And now by the change of base formula, this is just the natural log of 7 over the natural log of 3. And we're done. Now, the other method you could use is go back to how we got the natural log, or the change of base formula in the first place. You could take the natural log of both sides. That would then move this exponent down. Now it's multiplication, so now you can divide, and you get natural log of 7 over natural log of 3. Same answer, 2 ways. Personally, I am going to do this method most of the time. I just like to write it in exponential form and use the change of base formula. The method 2 works just as well. I'm going to stay with method 1 here. You can use whatever one you want. As long as you get the right answer, I don't care. So let's look at 2 answers. 5x equals 20, and 2x plus 1 equals 12. So 5x equals 20. Write it in logarithmic form. Hopefully we know how to do that easy by now. This is just log base 5 of 20. So x is natural log of 20 over natural log of 5. And then we could put that in our calculator to then find what that is as a decimal, or we can just leave it like that. 2 to the x plus 1 is 12. This is going to be log base 2 of 12 equals x plus 1. Instead of just x, we got x plus 1. Now this is just natural log of 12 over natural log of 2. And we want to solve for x. So now I got to subtract 1 from each side. And there's my answer. Now if we wanted to simplify that That's natural log of 12, parenthesis to close it off, divide by natural log of 2, parenthesis to close it off, minus 1, and we get 2.585. You can get the decimal approximation, or you can write it out. I don't care, okay? The important thing is, though, you need to show multiple decimal places. I do not, I repeat, do not want you figuring this out by guess and check. Do not do this by guess and check, where you just start picking numbers and eventually get it to work, okay? We did that previously. Now we can solve it exactly. Before we have a problem, I'll come back to that, such as this. The cost of apples increases 2% a year. If it now costs $3 for 5 pounds, how long until 5 pounds costs $5? Now we need to go back, use our formulas. On this homework, we're going to have to use those formulas, those compound interest formulas, those continuous interest formulas. All those formulas we're still going to have to use on this homework, so you need to pull them out. So now, it costs $3. It increases 2% a year, so that is plus 0.02 t, or 3 times 0.02 t. And we want to know, when does that equal $5? Now, when we did this problem previously, we just guess and check. We get 1.02 to the t equals 5/3, and then we would just guess and check. 4, 4.1, 4.2, 4.15. We just can figure it out. Now we don't have to. Now we can rewrite this in logarithmic form, log of 1.02, 5/3 equals t. Change the base formula, that is natural log of 5/3, divide by natural log of 1.02. Now, what is that in terms of a decimal? We could put that in the calculator. I have that right here. So that would give us 25.795. Now that is 25.795 years. Let's say we want to write that in terms of months. How do we do that? Well, we have 25 years, so we could subtract the 25 and get 0.79585 as a decimal. That's in years. So if we multiply that by, those of you taking chemistry know how to do this, 12 months over 1 year, we get 0.79585103116 times 12, and we get 9.55 years cancel, months. So now we have 25 years, 9 months. Let's go further. Let's go days. So now I subtract 9, and that gives me 0.55 months. Well, how many months in a year? We're going to make it simple. We'll say 30, rounding them all off. 30, so that's 16.51 days. So that shows you how you can kind of convert it into months, years, months, and days. So 25 years, 9 months. Well, actually, what month would that be? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that is September. There is only 30 days in September, so that worked out since we know 9 months in. Was that October? Let's do it. It's October, isn't it? So we'd be into the 10th month. So let's multiply by 31. We get 17. So let's go with that. 17.06. So 9 months and 17.06 days. So 25 years, 9 months, roughly 17 days. Okay. All right, homework, worksheet, exponential equations.